Is this the next Tesla bot killer? Galbot just unveiled its brand new ET1 humanoid with several new features. So today we're taking a closer, slower look at the preview trailer and then some insane real-world demos. But first, let's look at the exterior of this new ET1 model from Galbot. It's nicknamed the Galaxy Star Kid, and this is its high-definition head, then zoomed in to what looks like a power bar built into its chest. You can see here some anti-pinch fabric around its shoulders. Then there seems to be some pinch points potentially in its joints. Comment down below if you think that this would be safe for children. This is a bit smaller than your average person, about 4 feet, judging by some of the demos. Look at the way that the legs are able to articulate, specifically in its feet. And in just a moment, I will show you this robot training in real-world scenarios and then showing off its agility, specifically with the way that its feet are able to articulate to do such fluid movements. Here's a full body shot of the entire robot, but we still don't know how many degrees of freedom it features. But what's even more impressive than the ET1's physical exterior is actually its AI brain. This is called the Astrobrain, and it has 3 components to allow the ET1 to watch, learn, and do like never before. And in this demo I'm about to show you, you'll see the entire learning process for a whole dance routine that's quite impressive. But it works with these 3 components, the first being the cerebrum of the Astrobrain, and this handles understanding and high-level planning by unifying 2 previously separate approaches into one model, which allows this robot to anticipate physical consequences of an action before it's decided its next move. Then component number 2 is the brain bridge, which connects the cerebrum's high-level reasoning to the cerebellum's low-level motor execution. And this leads to component number 3, the cerebellum, or the Astrobrain WBC, which manages low-level millisecond fast physical coordination, balance, and motor skills across dozens of joints, allowing the robot to dance with next-generation fluidity. Comment down below if you think that this could be the smoothest robot dance so far. And this cerebellum actually has 80.4 million parameters, and it was trained on about 100,000 hours of diverse human motion data, which allows it to really control its whole body in a way that we haven't seen yet before. And they're saying that the price tag of this robot is going to be somewhere between $50,000 to $100,000. But because it's such a small robot, tell me down in the comments whether or not you think it will be less than $50,000 and if there should be some type of a leasing policy for this robot. Next, Engine AI's T800 was just deployed in a real-world factory, and here's some point-of-view footage showing its dexterous hands sorting tasks for the first time ever. And we can see that these are 3-fingered dexterous hands, and it's using its vision language action model as well as whole-body dual-arm coordination to be able to recognize these items and then sort them properly. And along with this pick-and-place task, you can see here the robot also features visual recognition system, not just for components that it's working with in its environment, but it can also detect whether or not another robot is within its vicinity so as to not bump into it or other objects nearby. And along with some impressive full body motion control here, they also showed a demonstration of this robot picking up a payload with one arm and balancing. You can see that it walks here quite steadily, but the question really is how much is inside of this briefcase? Is it 5 pounds, 50 pounds? And of course, these robots can collaborate together, and right now they're already working side by side with humans. But another Tesla robot challenger from American company 1X just showed off its new video of the Neo being prompted to squat down and walk. And this is a first shot take, and the robot is getting smoother in terms of its movements. But comment down below and tell us whether you'd go for Galbot's ET1 or 1X's Neo. At the same time, the biggest labs in the world are currently investing in the frontier of embodied AI, as Meta just released new evaluation results and demos detailing the multimodal capabilities of its Muse Spark 1.2, including a robotics setup that splits reasoning the same way that we just saw, one high-level model planning the task and a separate model handling the physical execution. In fact, Meta is using a specialized Muse Spark variant as the planning and orchestration layer for physical tasks. The system splits manipulation into two levels, where a high-level planner handles scene understanding, distinguishes between similar objects, and breaks a goal into subtasks, while a separate Muse Spark Vision language action model carries out each step. And demonstrated examples include sorting a hairbrush from a makeup brush, packing lunch items into a box, and navigating an unstructured environment to locate a rubber duck. But robotics is only one part of what this update covers, because on general multimodal benchmarks, the picture is competitive rather than dominant. Muse Spark 1.2 runs neck and neck with GPT 5.6 Sol on Zero Bench, which tests general visual reasoning, and comfortably outperforms Claude Opus 5 and Gemini 3.7 Flash. Then, on Simple VQA, a visual question answering test, Muse Spark 1.2 is only beaten by Gemini 3.7 Flash. But Meta says the model's real strength shows up once it's allowed to use tools rather than reasoning from a single glance. Letting it inspect visual inputs more closely before answering produces a larger performance jump than the improvements seen in Muse Spark 1.1 under the same conditions. And on visual coding, the model converts images or video directly into working code for web pages and games, then re-examines its own output to self-correct. Then, on the third-party Design Arena leaderboard, Muse Spark 1.2 currently ranks first for converting video into a website, places close second for converting a single image into a website, and sits in third for image to front-end conversion, trailing Kimi K3 and Claude Fable 5 in that category. And when it comes to audio-visual understanding, Muse Spark 1.2 pairs video comprehension and dense captioning with agentic tools including web development, real-time search, and spatial grounding, aimed at turning raw video input directly into actionable output rather than passive description. And Meta also previewed Wild Artifact Bench, an internal evaluation built to score agents across any task type, deliverable format, or verification method, instead of relying on fixed correct answers. Meta says frontier models still struggle with real-world agentic work, like producing production-level games, which the new benchmark aims to capture. It compares outputs from a tested agent against a baseline agent, with automated and human judges choosing a preference to generate win rates, which is an approach that Meta says broadens task coverage since nothing needs a predefined right answer. And Meta has already released a handful of example tasks from the benchmark publicly, including analyzing a cardiac ultrasound sequence and building a driving simulator trainer. Anyways, like and subscribe, and check out this video here for more of the latest in AI and robotics news, and thanks for watching.